Okay, folks, we're just trying to get things set up. Hopefully we're doing this live. So it seems like we're on live now. I don't see anyone on the chat system or anybody watching. Hopefully that will change. In any case, here's going to be the lesson on, we're going to kind of review periodic table of elements, especially looking at the periodic table and how to take the information from, say, one of the cells of the periodic table and how to draw the Bohr diagrams so we can look at things like ions and things like that. So, the entries in the periodic table are given by the atomic number or the number of protons. Sodium is the 11th element on the periodic table and has 11 protons. The atomic mass is composed by the number of protons plus the number of neutrons. Now, protons, and I think actually might be the next slide. So, if we're looking at this cell here, we've got, and this arrangement may change depending on the periodic table, but typically you will find the atomic number in the top corners, either the left or the right. You'll find the element symbol and its name in the middle, and on the bottom you will find its atomic mass. So most times it'll be a decimal 22.99, and they'll round it to the nearest whole number to make it simpler. Now, one of the key things from this is the number of protons is going to be 11, and the number of protons plus the number of neutrons is equal to the atomic mass of 23. Well, if there are 11 protons, how many neutrons would I need in order to get 23? Well, it would be 23 minus 11, so that would make it 12. So that tells me how many protons and how many neutrons I have. So flipping over to the next page, we've got, remember that atoms are made of the three things: electrons, protons, and neutrons. Well, electrons are very small particles which have almost zero mass and have a negative charge. We can find these orbiting the nucleus in quantized energy levels. So that means at each electron ring there's only specific energy levels that those electrons could have. Protons are large particles, and the atom's mass is mainly composed of the mass of protons and neutrons, and they have a positive charge. They're found in the center of the atom, known as the nucleus, and the rings of the electrons encircle the nucleus, which follow the specific pattern. So remember I talked about how there's certain energy levels? Well, these energy levels follow by the number of electrons within each quantized shell. In the first ring, you allowed 2. In the second ring, 8. Third ring, 8. And then it goes farther and farther with 18 on each, 32 on each, etc., etc. But for the most part, we're going to just use the first 5 rings. So again, making atoms. So now we're going to look at making the atom based off the information that we're given, i.e. the atomic number, and the atomic mass. Now, before I start, remember, I want to remind people that atoms are electrically neutral. So what that means is that there's no charge on them. I.e., if I bring in, if I've got 3 protons, then I need to have 3 electrons, because protons are positive charge and electrons are negative charge. So we need to have a balance in those two. So let's try and make this. So starting with the protons, we've got 3 protons. So therefore, we're going to drag 3 of those to the center. Now, let's look at the number of neutrons. Well, the atomic mass says that it's 7. So 7 has to equal the number of protons plus the number of neutrons. But I already know that my number of protons was 3. So then, plus what will give me my number of neutrons? Well, if I subtract 3 from each side on this equation, I'm going to get 4 is equal to x. So therefore, I'm going to need 4 neutrons. So again, going back and throwing in my 4 neutrons. There's my my nucleus. Not a very nice one, but it's there. Now, if I've introduced 3 protons, there are 3 of them here. That means I've got 3 positive charges. So in order to make this neutral, how many negative charges would I need to introduce? Well, I'd need to introduce 3 negative charges so that I have 0 negative or positive charge. So negative charges are indicated by an electron, so I can put 3 electrons in to my diagram. So 1, 2, 3. Now, is this correct? And if I could hear everyone's voices, then they would be screaming no, because this is not correct. So what we need to do is, because it's not correct because the inner shell could only have 2 electrons. So since it can only have 2 electrons, therefore my first shell here can only have 2, so therefore my second shell I will have 1 of these electrons. Usually electrons start, if we're talking about a clock, it would start on the 12, and then it would be put on all the quarters. So 12, then 3, then 6, then 9. When it's only 2, it's just 12 and 6. So for the second ring, an example would be there would be a second electron. We keep going clockwise, so we put the second one at 3 o'clock, then the third at 6 o'clock, fourth at 9 o'clock, and then we would double up at 12 o'clock as we go around. Okay, so after we've done that, we've got our completed lithium cell. So let's look at this example here, this oxygen. So there's an 8 in the top right-hand corner, and what did that represent again? It represented the number of protons. So therefore the number of protons is 8. How many neutrons are there? Well, remember that protons plus the neutrons has to equal 16. Well, 8 plus 8 gives me 16. So how many electrons do I need? Well, in order to keep this thing neutral, I would need to have 8 electrons. Go on live. Go on to YouTube. So that was just a couple of students there trying to get into the classroom, kind of like zombies. In any case, so we've got 8 protons and 8 electrons. So what we're going to do is go ahead and watch that. Let's just continue this at a later moment. I gotta go answer the door. Okay, coming back to this, so now we're just going to complete the cell by introducing all of its protons and electrons. So we've got 8 protons, 8 neutrons, and 8 electrons. So I'm just going to introduce 4 protons and cheat a little bit. Clone to give me 8. Introduce 4 neutrons. Clone those bad boys to give me 8. So now I've got 8 and 8, and again, going to introduce 8. Remember I said we're going to start at 12 o'clock, then 3 o'clock. Yeah, I'll put 6 o'clock down there a little bit. 6 o'clock, 9 o'clock. So how many total is that? Well, there's 2 on the inside, 4 on the outside, so that's 6, 7, 8. And that's our completed oxygen atom. Looking at argon, let's just try and go through this one a little bit more quickly because we've kind of done this already now. So protons is on the top, 18. So number of neutrons is the protons plus neutrons has to equal 40. So subtracting 18 from 40, we're going to get 22. Number of electrons needed, well, we're going to need the same number of electrons as protons to keep our element stable and neutral. So this is a lot harder to draw and fit all these guys in, so that I'm just going to introduce protons and electrons and throw in that I've got 18 of these and 22 of those. Similarly, I'm just going to simulate my electrons by this blue dot just to make it a little faster. So I've got 2 on the inside, 8 on the outside, so that gives me a total of 10. Now what was on this third shell again? Again, it was, if we can go back, it was 8. So I can introduce 8 on this outer shell, and that would give me a total of 18. So notice this is actually a special case where the shell is complete. When we have these complete shells, that means it's the most stable, and it happens to be all of the noble gases are stable at with full outer shells. So that's just a little key point, that the most stable items are going to be the noble gases, which are the far right column of the periodic table. So now we're going to work backwards. So we're going to look at the Bohr diagram, or the atom, and we are going to create the cells from the periodic table. So recall again, what was this yellow section? Well, the yellow section was the number of protons. Down below in the green we had the atomic mass, which was the protons plus the neutrons. And in between we had the symbol's name, and we had the symbol for the element. So let's just look here. Looking at my my diagram here, I've got, let's just see here, I'll zoom in, 5 protons, so we're going to put a big old 5 in the top corner here. And we've got 6 neutrons, so that means our atomic mass is the number 5 plus the number 6 to give us 11. So 5 protons plus 6 neutrons is 11. So our atomic mass is 11. And how many electrons do we have? Well, we've got 5, so we know that it's a stable element, and it's neutral because it's got 5 protons and 5 electrons. So if we're going to go back to our periodic table, we need to find what has 5 protons, so we can count through them here. We've got 1, 2, 3, 4, 5. So we're looking at boron. So we're going to move back. We found out the symbol is just a big old B, and we would write boron. Okay, so let's try this one. Same idea, just with some higher numbers. So looking at the number of protons again, up in this corner, looking at my number of protons, I've got 9 protons, so I know it's the 9th element in the periodic table. How about the number of neutrons? We've got 4, 8, 10, so therefore my atomic mass is going to be 9 plus 10, which is 19. You don't need to include this, just the number 19. So let's go ahead and see what element it is. Flip back, so look at number 19. Again, they're all numbered for me, so we're looking at K, which is potassium. And that's all it takes, folks. Now, ions are special types of atoms such that their electric charge is not balanced. So, because it's not balanced, we're going to get these things called ions. So we're going to have either an excess amount of electrons or an excess amount of protons, and that will give us our plus or minus charge that's associated with the item. One person online, looks like now. So, if we look down here, we've got some elements here, and again, these ones are all neutral because the number of protons is equal to the number of electrons. If I kind of scroll through a little bit here, now, here's some important information. If it has more electrons than protons, so if it has more electrons than protons, therefore it's going to have a larger electric charge, a negative electric charge. If that is true, then it's going to be called an anion. If it's an anion, it has more negatives, so more electrons. If you lose an electron, so it has fewer electrons or more protons, that means it's going to have a larger positive charge, and therefore it's going to be called a cation. So cation is if there's a surplus of positive, anion if it's a surplus of negative charge. Now, one other key term. sometimes we're gonna actually be looking at Lewis diagrams soon, and they only care about the electrons in the outermost shell. What those things called in the outermost shell are valence electrons. So that's what's going to be important coming up soon. But anything in its latest or external shell, it's called a valence electron. So how do we write if something is an ion versus something is being an atom? Well, in the case of this textbook, they went through the example of sodium. So if we ended up losing an electron, if we lose an electron, so we start off with our sodium and it's going to be balanced, and if we're going to be able to tell if it's balanced if there's nothing here. So there's just it's just Na by itself, so there's nothing up there. If we have a surplus of negative charges, so extra electrons, or and it's going to be extra electrons, so somehow the atom has picked up a few extra electrons, that means we're going to have more negative charges, and it'll indicate by a negative sign. So therefore the atom of sodium will have extra electrons and therefore have a negative charge. Now if I had negative or 2 extra electrons, that means I'm going to have 2 extra negative charges. So we're going to indicate it by a -2. So the 2 indicates the number of electrons that are extra, and the negative indicates that you have electrons that are extra. So what if we ended up losing electrons? Well, if we, again starting with sodium, nothing up there, so it's neutral. If we lost electrons, then we're going to gain positive charge. So let's say the example where we lost 3 electrons. So we're going to have 3 positive charges remaining because we're going to have an excess amount of positive charge that is equal to 3. So in our top right hand corner we should see a +3. So again, the number indicates how many electrons are lost, and the positive means that we've lost some. So let's look at building some ions. Again, let's start with our lithium example that we started with. It's fairly simple. So we've got 3 protons and 3 electrons. Well, we kind of talked about if we lost an electron, so I take one away. Well, now we have an excess number of protons. So I'm going to have 3 protons versus 2 electrons. So I'm going to have 3 positive charges, 2 negative charges. So I'm going to end up with a +1, and that would be indicated up in this corner here. Now, what was it called when I gained an atom, or gained an electron, or lost an electron? Is this an anion or a cation? Well, if you can't remember, the cation is when it loses an electron, or we end up gaining positive charge to it. So this is actually going to be a cation. So if I kind of reset things again, bring in my electron, let's bring it up here, and reset this back to 0. Well, what happens if we were to gain a couple electrons? Clone an electron here, and I clone another one. Just put it up here so it's easier to see. So I've got now 5 electrons. So my negative charge is 5 and my positive charge is 3. So therefore I have a surplus of -2 charges. So therefore I've got lithium -2, and we would just write it as lithium -2. So that's how we indicate our ion. So it's time for you to show me what you know. So using the PHET atom builder, practice by making some atoms. First of all, use the atom builder, and inside of there you have the chance of throwing in protons, neutrons, and electrons, and figuring out if it's going to be neutral, an ion, etc. by the number that you put in. When you think you're ready, I want you to play the 2 following games. So I want you to play this first one, which is basically they will give you an element, you need to build it, or they'll give you pieces of it and you have to build it. And the other one is they will give you the Bohr diagram and they want you to complete the information on the cell. Once you've done that, once you finish the first one, take a screenshot of the results. So you're going to go through and it'll say, oh, you got 4 stars out of 10, or 4 stars out of 5, sorry. Take a screenshot of that, and if you miss it, don't worry, we can do it at a later date. And we're going to paste that into an Adams worksheet and then submit that all into the Dropbox. So take a screenshot after you finish the first game, take a screenshot after you finish the second game. It would be great then if you missed those, you can take a screenshot right here at Choose Your Game, and the stars will be filled in depending on how you do. Okay? So go ahead and complete those, submit it into, paste your screenshot. So if you're using a computer, you can push the function button, so the little FN, plus print screen. So let me just try to figure, it just says PRTSC, or you can just hit the button by itself. What it does is it takes a copy of whatever you see on the screen. So then when you're in the Word document, you're going to paste it. So right click, choose paste, edit paste, or Control V, and you'll see it. If you're using a tablet or device, you can just use the screenshot button, typically by holding the down volume key and the power button for a couple seconds. After that, then you're just going to put those images into the Word document that you'll see up there and throw that all into the Dropbox. Well, if you have any questions, you can go ahead and post something in the chat, but again, I don't see anyone online, so we are going to go ahead and finish up here, and we will see you soon enough. Thanks for watching.